All right, so here we are, AP Calculus. Today's date is Tuesday, April 23rd, 2019. I do have an eraser that you can use. You can borrow this one. Can I throw it? Oh, left-handed. Someone play softball. All right, so this problem should have been on the test, but it's not because I messed up. But let's go ahead and spend some time reading it. Anyone want to read it?
I'll do it.
Go for it.
Mighty Cable Company manufactures cable that sells for $120 per meter. For a cable of fixed length, the cost of producing a portion of the cable varies with its distance from the beginning of the cable. Mighty reports that the cost to produce a portion of a cable that is X meters from the beginning of the cables is 6 square root of X dollars per meter. Note that profit is defined to be the difference between the amount of money received by the company for selling the cable and the company's cost of producing the cable.
All right, so yeah, cool. Just as a way of thinking about this problem, we have a positive amount of money that's happening. So we're making money here. So this is a positive amount here, $120 per meter. But then you have a negative amount of money down here, negative 6 square root of X. All right, so we need to find profit. So both of these are a rate, right? $120 per meter, 6 square root of X dollars per meter. These are both rates, which means if I want to find profit or just a net amount, I'm going to do what? You're definitely going to be subtracting, but what symbol am I going to be using?
Oh, an integral?
An integral. If I take the integral of a rate, it will give me the amount. All right, so for part A, I'm going to take the integral of the positive minus the negative. So it's going to be 120 per meter, so 120 minus the 6 square root of X. 6 square root of X. And that's going to be a 25 meter cable, so from where to where?
0 to 25.
There it is, 0 to 25. And that's going to be dx. And this is number 3, so if it's number 3, that means it's not 1 or 2, which means you don't have a calculator. And I don't know if I put that up here, I did not. You don't have a calculator. So for this one, we have to do this by hand. I'm going to take the antiderivative of 120.
Which is 120x.
Yep, and then if you want to do the shortcut method, you can. Does anyone prefer the shortcut method? We do? Arrow? No? Okay, we're doing both methods. Rochelle, you do the shortcut method right from the very beginning. This is going to be 120x and then antiderivative of 6 square root of x. Again, that 6 square root of x, I can rewrite that as 6x to the what?
1/2.
Yep, 1/2. And antiderivative of x to the 1/2 is? Add 1, divide down.
2/3 x to 3/2.
Yep, so it's going to be, I'm going to write that out, that's 6, and then I'm also going to multiply that by the 2/3, and I'll have x to the 3/2 evaluation bar between 0 and 25.
So it'd be 4x to 3.
Exactly, yeah. The 6 will cross cancel with the 3, so it'll just be 2 and 1. 2 times 2 is 4, so this whole thing is 4. All right, now I need to actually do the evaluation. All of these things are pretty short, so I can come down here to the next line. All right, so 120, and I'm going to plug in 25 first, so 25. And I'm going to subtract 4, and then I'm going to plug in 25 to the power of 3/2. This whole thing is when I plug in 25. What happens when I plug in 0? Yep, so minus 0. Pretty straightforward. All right, the hard part of this one is 25 to the power of 3/2. I'm going to do 25 to the 1/2 and then take that to the power of 3. So 25 to the 1/2 is?
5.
5 to the 3 is?
125.
Yeah, so then I have to do 4 times 125. But this whole thing right here, I'll make a note that this is 125. So 25 times 120.
It's 3,000.
That was really quick. How do you get 3,000 from? Okay, so 2. It's going to give 24. 5. It's going to give 6. Yeah, 3,000. You're able to do that in your head that fast?
Well, I did the shortcut.
Oh, yeah, okay. And then from there, we're going to.
125 times by 4 equals 500.
And that should give us 2,500. All right, we have to be careful here. Do we need units? Yeah, because we're talking about profit. 205, yeah, $2,500.
Should we say per meter?
Exactly, yeah, that's a super important distinction to make. This is in dollars, not dollars per meter.
Oh, because already asking us how much it's made in 25 meters.
Exactly, yeah.
Oh, okay.
And the other way of thinking about it is if you're taking the integral of a rate, the units should not be rate anymore. It should just be that units. Cool. So there is our final answer for part A. We box it.
We could put a dollar sign, right?
You can put a dollar sign. Yep. I guess it's interesting because I think this test is sometimes given in Europe too. I guess if you're studying abroad, I just wonder if you'd ever use euros in these problems. I don't know the symbol for euros. Does anyone else?
Isn't it like a curvy? But what about pounds?
We said different things for the symbols for
Pounds? Yeah, I don't know all of
This
these
is like the euro
symbols.
symbol.
except for it's an E, that's a T.
Dude, yeah, it's more curved. It's more like a C.
It's like a C with a line
That's
cross.
Yeah.
okay.
I remember
the
it.
pound symbol
No.
for English pounds is like this. Or maybe that's backwards.
It's like an L, right? A curly L.
I don't know.
Yeah.
What about like Mexico?
Oh yeah. Pieces. Or doll. Are there dollars in this?
They're not dollars, like honestly, like they have like a kind of like a dollar bill of a 50.
Yeah, it's kind of like a cursive L.
That's the same symbol.
So it was off.
Oh yeah.
What about for Mexico?
Pesos?
Yeah.
Wait, Mr. Zell, do you want to know something literally insane since you guys are already on a slight tangent?
Sure.
So, we're playing Emmanuel today, right? And, like, their coach isn't going to be allowed to be on the field because in the last game, the coach spit on the umpire. Isn't that just...
I wish we saw that. I want to see that.
That's not good.
Yeah, me too. Honestly, that would be, like, so...
I guess they still use the same symbol that we do,
Yeah.
or Mex in front of it.
Or just an S.
Interesting. Okay, let's go back here. Coming back from our tangent. So we need to explain this thing. So what does that mean in the context of the problem? So 6 squared of x, that's talking about their cost. So how are we going to say this? I'm going to use the word cost. Boom.
Oh,
Total
the
cost.
total cost.
125 to 30.
No, the total cost in dollars.
Oh yes.
Total cost
From 0 to yeah.
Yeah.
No, from 25 to 30.
Yeah.
Like, you...
to produce.
It's 14. Oh my god. That is so...
From what are my bounds? 25 to 30.
25 to 30.
5 to 30 meters.
Oh my god.
Nice. All right, we got all the units correct, and we're on to part C. Write an expression involving an integral that represents the profit that when I'm k meters long. All right, so what am I going to do? So you don't even need to simplify it either, but
Would
it's
it be from the integral of 0 to k
it is now the integral of 0 to k of what?
of 120?
The first one.
Yeah.
Yep,
So
basically.
this, yeah.
Yeah, I'm just rewriting the same formula that we had up here. This thing, dx. And yeah, I mean, that's done. We could also separate this so I have 120k minus the integral of 6 square root of x from 0 to k. But I think this is fine. That's it. Part D.
This is gonna be one of those table ones.
Yep, exactly, because we're looking for maximum. So we need to find CV. So we'll set up our table down here, but we need to find CV first. CVs. We'll do that up here, and then we're going to set up a table. I have technology. Let's make nice straight lines. Shrink. Oh, how's that straight? I mean, it's straight, but it's just not. There we go. All right. So for X, I'm going to do start plus change. That's going to equal the end.
Do we have to put like that? Like saying like X and start plus change and equal to end?
You don't need to put exactly the same thing, but you do need to make a table
Okay.
and know what goes where. I'm putting those so you know what's going where. All right. Obviously, we need our endpoints, and we don't have any points except for the start point. So we definitely need a start point. We don't have an endpoint. We could come out here to infinity if we want.
Can we go to 30 since that's what they give us for part B?
Nope. It can go to anything. We're on a totally new problem that's ignoring everything from A through C. All right, so we have no end value, which means our end value is probably going to be our CV. So let's work for CVs. CVs, I'm setting the, what's the definition of FCV?
Prime change?
Really close. F prime
Sign
Equals 0.
equals 0.
Oh.
And more specifically, if I do a sign change, that's called what? F prime sign change.
Double prime.
No, F prime sign change, what does that mean?
It means F prime.
Nope, F.
No, I don't know.
You won't forget this.
F relative.
Maximum relative extrema.
Relative extrema, exactly. And if it goes from a positive to a negative, that's F relative.
Maximum.
And if F prime goes from minus to negative,
It's no.
minimum. All right, perfect. So CVs, I have to find F prime. So the idea is doing F prime set equal to 0. So what is F prime of X?
It's that formula 120 minus 6 square root of x.
It is, yeah. So I'm taking the derivative of this thing, and I just get 120 minus 6 square root of x, because the derivative, F prime, of the integral is itself. It's the inner. It's the, what is this thing called? The integrand part. Okay, now I set that equal to 0, because that's the definition of a CV. And I'm going to solve. I'm going to add 6 square root of x to both sides. So I now get 120 is equal to, just do right here, is equal to 6 square root of x. Let's divide both sides by 6, and I get 20 is equal to square root of x. Did I do something wrong? Because that's not a nice number.
Isn't?
No, it isn't.
Well, no, you square both sides, and that's 400.
Oh, I don't know why I was thinking I needed a square root. But yes, you are totally correct. I'm going to square both sides, and therefore, coming up here, actually I have technology. What am I doing? I can just move this table down. Ah, ha, ha.
Cheater.
All right, I'm going to move you down, and therefore we get, I'll do this in red. Come on. Oh no, I just changed all the table to red. I didn't want to do that. Grab everything but the parenthesis. Technology. It's nice when it works.
Everything is nice when it works.
All right, now that I've figured out how to correctly use my technology, x is indeed equal to 400. So we do have a CV.
It could be negative 400. Yeah? No?
Yes, you're right. It could be negative 400, but is that in the domain?
Oh, no.
Yeah. So that's always an important check. It needs to check. We need to check negative 400, but it wasn't in the domain because you can't produce negative 400 meters of steel cable. All right. So we only have to check these two numbers. Do we have any start value?
Hey, what?
Do we have any start value?
Yes, probably.
Yes. What is our start value?
I don't know.
0.
Yeah, 0. And we didn't get a start value. The start value should be in the problem somewhere, and they didn't have any start. Like they say that it sells for 120 per meter, but that's not our start value. They don't have a start value, and it makes sense, right? It should cost you $0 when you're initially doing something,
Well, it should be variable. No.
unless you're like a U-Haul and there's an initial cost, I guess. All right. Anyway, 0 is our initial cost. Our change is going to be that integral. this formula over and over again. So it's the integral from 0 to 0. I'm not even going to worry about that guy because it's not going to do anything. This one I do care about. The integral from 0 to 400 of 120 minus 6 square root of x. I don't know why I did there. 6 square root of x. All of that thing dx. I need to actually find him yet again. When I plug in 0, obviously I get 0. This one I need to actually calculate. Let's do that off here to the side. So I guess I'm going to use this space over here. So this integral between 0 and 400 of 120 minus 6 square root of x dx. Antiderivative of 120 is going to be 120x. Antiderivative of this guy is going to be, we've already done the antiderivative. Let's just take him. It's going to be 4x to the 3 halves. So minus 4x to the 3 halves. Evaluation between 0 and 400. When I plug in 0, nothing happens, so I need to only plug in 400. That is a big, big number.
48,000.
You did for this one. 4,800 minus. Okay, square root of 400 is
48,000. That's 4,800.
Oh, this is 0. That's right, because 0, 0, 0, there should be 3 zeros. I count 1, 2, 3 zeros. There should be 3 zeros in this one as well. All right, and then the square root of 400, because I'm taking it to the 1/2, should be 20, because we squared 20 to get to 400, right? Square root of 400 is 20. 20 to the power of 3, it's 8,000. And that has to be multiplied by 4. So don't forget that. 4 times 8,000. All right, 4 times 8 is 32. So I'm going to
32,000.
32, 1, 2, 3, and I have 48, 1, 2, 3. So 48 minus 32, that's going to be 16, so 16,000.
Which is definitely bigger than 0.
I thought it was small.
I mean, on a scale, if this is measured in atoms, that's very small.
Yeah, but it's still bigger than 0.
It's definitely bigger than 0. All right, so our answer, what is it actually asking for? Just finding the maximum, not when it happens. On the sale of one cable, so max profit is $16,000. You don't need to have a comma. I'm doing it for the sake of looking cool. 16,000 at 400 meters. It didn't ask for the 400 meters.
Attention softball girls, it is now time to leave. Please gather your things and meet Shelley in the back of the school. Thank you.
Again, it didn't ask for 400 meters, but we're going to give it in every case. That way we can't lose points in case it did ask for that.
I'll let you help.
Yeah, I'll spit on the umpire.
All right.
Yeah,
Don't spit on the umpire. That sounds like a bad idea.
I'm just kidding. Oh my god, that was good.
All right, we're on to number 12. Yep. Rochelle, you're going to watch the video from number 12, right?
Yeah.
And now I'm talking to Rochelle online. All right, so the rate of change of the volume of a water tank. Okay, this is from the actual test, I believe, on number 12. Which of the following is a differential equation that describes this relationship? So let's underline this part. It's directly proportional to the square root of the volume. And what am I talking about here? Am I talking about V or V prime? Talking about V prime because it's the rate of change of the volume. So this thing means V prime or dV dt. So just from that alone, we're talking about not A and B. Let's automatically cross off A and B. We're talking about V prime, and it's proportional to the square root of the volume. Which one of these has a square root of the volume? Well, that doesn't have a square root of the volume. It's between D and E, but it's not inversely proportional. That would be D. So this is inversely. I don't know how to spell inversely. I'm going to inversely, I'm guessing, inversely proportional. This one is directly proportional. This is directly proportional. So the answer is E. have a square root of v in there. All right, questions. Get your questions here. Nice hot questions. All right, on to number 14. Oh boy, what do we immediately think when we're looking at 14?
Product rule.
Why product rule?
Because there's two x's.
Yep, that's the general idea. Arrow, what's product rule?
1d2 plus 2d1.
There it is, plus 2d1. All right, so 1 is x squared. d2, what's the derivative of sine of 2x?
2 cosine of 2x.
2 cosine of 2x. Good job doing dinner. Dinner, again, was that 2. Doubter was cosine, and then you have to leave the 2x in there. So that's 1d2 plus, now I'm going to do 2. 2 is sine of 2x. Sine of 2x. And d1, what's the derivative of x squared? Anyone?
2x.
2x, there it is. All right. And notice that these both have a 2. So I'm going to underline what they have in common. They both have a 2, and they both have an x. So I'm going to factor both of those things out. So a 2x comes out front. And what's left over? I have an x cosine of 2x. And I'm also left with a sine of 2x. And notice that it's x times cosine, and there's a plus in between, x cosine. Looks like our answer is E.
Write it. Oh. For some reason I feel like
All right, on number 15. So we have the derivative, and we're looking for where f is decreasing. All right, I automatically think of definition of f decreasing. What is that?
f prime is less than 0.
There it is. F prime is negative, is less than 0. All right, so therefore I need to set this equal to 0 and figure out which interval it's happening. I mean, I can probably tell that I'm going to have -1, 0, and a cube root of 3 over 2. But let's actually check what's going on. So this one is going to be a little bit tricky. X squared minus 2 over x is going to be set equal to 0. I'm going to add 2 over x to the other side, and I'm going to be left with, let's do this in another color, x squared is equal to 2 over x. Just added it to the other side. So far, so good. Now I'm going to cross multiply and solve because I have two fractions set equal to each other. So cross multiply and solve. I'm now left with, I'm going to come back up here, x to the power of 3 is equal to 2. And finally, solving by taking the cube root, I'm left with x is equal to, is it plus or minus or just cube root? Do I have a plus or minus or not?
I don't think so. Cube root.
Yeah, what do you think, Arrow?
No.
Yeah, you never do plus or minus when you have an odd power or an odd index. If it was even like the fourth root or square root, then you do need the plus or minus. So we only have one value, so automatically I'm going to cross off anything with a 0 in it. Chunk, chunk, chunk. And that one is randomly at -1. I think we already found our answer. It looks like it's E. Let's check if that's the case, because these have random other CVs. Again, CVs are when I set it equal to 0, so cube root of 2 is a CV. Let's actually check to make sure that is the answer. So here's my graph of x. I have the cube root of 2. Let's choose a value to the left and the right. What are some good values to check?
2.
2 and 0. I don't actually need to check 0 because I have an odd power. I know that it's going to flip over this critical value. Let's plug in 0 into my f prime function. So 0 minus 2, oh, I can't plug in 0. Oh, that's why we have zeros in there. Okay, so let's come back here. Let's not cross out those zeros quite yet. You can't plug in 0. So how do I say this? CVs, what's the definition of CV?
F prime equals 0 or doesn't exist.
Yeah, or does not exist. And that last part of the definition of FCV is what gets us. It does not exist at 0. So let's also get rid of this. So we have another CV here at 0 because I can't divide by 0 right here for the 2 divided by x, so I have another CV here at 0. Very important distinction to make. Okay, so 2, 1, and -1, those are the values I'm going to be plugging in. When I plug in, let's plug in 1, that's a nice value. I'm going to get 1 minus 2, it's going to be a negative. And then it should flip over this critical value, so it should be positive over here. And I don't think it should flip over here because that's a does not exist point, I think. Let's actually test. So if I plug in -1, I get 1. If I plug in -1, I get +2. Oh, it does flip. Did everyone else get that as well? All right, so it's decreasing between 0 and cube root of 2, which the answer is D. So I need to write out the definition for the notes as well. CV is where f prime is equal to 0 or D and E. And that's the key part. And we'll write that in our notes as well. dn E at x equals 0 because of this x coordinate right there. Cool, cool. And our last problem together before you go off and try your own stuff. We have this function 2x e to the x. The graph is concave down. All right, what's the definition of f concave down?
Double prime is less than 0.
There it is. F double prime less than 0. That means we have to take the derivative twice here. So I need to now find f prime. Ooh, what are we thinking as soon as we think about taking the derivative of that function, Arrow?
This function is very familiar. I've done this a lot of times. What was the question?
What are you thinking when you see this function? Like, uh-oh, I can't do that because of a certain problem. Or I'm going to have to use this rule. Ben, you should be doing this already.
Rule.
Yeah, product rule. Because
Is there like
two x's. Yep. All right, so product rule again is, so product rule, I don't know why I did the hyphen, product rule is 1d2 plus 2d1. That'll help us as we're moving through this problem. F prime of x is now equal to 1, which is 2x. D2 is e to the x. E house is really nice to take the derivative of. And then plus 2, which is e to the x. D1 is 2. All right. Can we simplify this at all? Not really. I mean, I could factor out an e to the x, but then I'm going to have to use ugly power rule again. You're using power or product rule again, regardless of what's happening. So let's go ahead and take the second derivative.
Maybe you can just copy it down though, because you still have 2x e to the x.
Oh yeah, and then you just kind of put this whole thing recursively back into that thing for when you're taking the derivative. So f double prime of x, as Ben said, I know what the derivative of 2x e to the x is. It's right here. So I'm going to rewrite this whole thing down. 2x e to the x plus, I guess, 2e to the x. That was the derivative of this guy. So that was in red, and I'll do this one in orange. This one is going to be plus 2e to the x. So this one came down here. This one came into two parts. All right, and then I can reduce this a little bit. So this is the same thing as, I guess, how many of these e to the x terms do I have? I mean, this one right here reduces to 4e to the x, but I can reduce it even more than that. Because I have 2x e to the x plus 4 e to the x. I can factor out e to the x, right? And leave the inside as...
Yeah, 2e to the x.
Oh, you can. That's even better. Let's do that. 2e to the x times inside, which is going to be what?
Plus 2.
X plus 2. Yeah, nice. Okay, this is the second derivative. We need to figure out where it's concave down. We need to set this thing equal to 0, which will find possible inflection points, and then we'll actually find concave down when we find the intervals if they're positive or negative. So right now we're going to set this equal to 0. E to the x can never be 0. So don't worry about him. Can never be 0. Never 0. So we only have to set x plus 2 equals 0. Therefore, x is equal to -2. There's our possible inflection point. Let's figure out where it's concave up and concave down by looking at a number line. So here's -2. I'm going to plug in a nice number. I'm going to plug in probably like 0. So when I plug 0 into my second derivative, which is right here, I haven't done anything to it, aside from factoring it out and making it look nice. When I plug in 0, I get positive here. That's going to be positive here, so I get a positive, and it should flip over, so it should be negative. So it's concave down when it's less than -2. Is there anything that says less than -2? Yes. A. Cool, cool. All right, that was the first page. Second page, front and back, are you guys on your own. I'm going to be working on the answer key because I haven't made that yet. I'll be working on it in front of you.